Hello, my name is Parham Golmohammadi, and today I'll be talking about my applied coursework presentation on email spam detection using neural network. For part A, I conducted a literature review on AI techniques for email spam filtering. I reviewed the evolution of spam filtering from rule-based systems to modern machine learning approaches. Key techniques I identified was naive Bayes classifiers, which achieved about 90% accuracy and was first introduced by Sohami during 1998. Then we have the neural network, then random forest, which could achieve 95 to 99% accuracy. I chose this domain because it provides a clear binary classification problem, and also the source and the resources I need are publicly available. For part B, I compared three AI models, as you can see here, and three AI techniques for spam detection. The first one was neural network, then random forest and k-mean. For neural network, they are a supervised learning model that excel at learning complex. For nonlinear relationships, they require label data, and they are more computational resources. They need more computational resources. On the other hand, for random forest, they built from assembling different multiple decision trees, and they provide feature importance, so we can see each feature and their effect on the result. And the last but not the least one was k-mean clustering, which is an unsupervised method. This means it doesn't require any label data. It groups email by their similarity, but they require manual interpretation to map the clusters to see which one is spam and which one is ham. I selected neural network for my main implementation because they can handle complex nonlinear patterns very well, and they align with my learning outcome that I want from this project. For part C and implementation, here we can see the system architecture. It has 7 stages. First we load the data, then we clean the data, extract the features from it, standardize it, and split it in between test and train dataset. Here we can see my model architecture. Input layer, we have 2 hidden layers, then dropout layer and output layer. Here we have the evaluation. We use confusion matrix, accuracy, precision, and recall for the evaluating different models and the outcome. This picture is a sample of my model, my neural network model, a simplified version to see how does it work over each epoch. When training the model, how would it affect the classification results? Okay, we're gonna get to the cells for code. Here we load all the essential libraries. Then here we load the data set. As you can see, we load it, get the head, then process the data set and remove the duplicates, extract the features from raw data set. It's gonna take a bit time. We can see different features and the numerical features. Then clean the data set one more time and prepare it to train the model on it. As you can see, we preparing for neural network, and here first we're gonna try it on a baseline model for a baseline model to see its performance on a simple model, not too complicated. Yes, and then we build the neural network. First we're gonna tune our hyperparameter. You can see different fixtures, and I chose the best one, which was with 17 features input layer, then 2 hidden layer, one with 128 neurons, the second one 64. Also we have a dropout layer, which is 3.3. We're gonna train the model here. While the training is complete, then we're gonna do a cross validation for our accuracy to see everything is stable. Then we're gonna test our model on test dataset, and use different evaluation techniques such as confusion matrix, then classification report, different curves such as ROC. Using these data and these information, we can compare our models, compare other techniques to this one, and see how they reacted over time, and with like large data set. And even we can delete a feature and see how would it affect the results. You can see differences. For port D, here we have port D. So basically for port D, I evaluated my neural network and compared it against other two techniques. So basically it's a comparison. Here we can see the analysis of none and their results in confusion matrix, and what was the results. Then for random forest, we can see actually perform much better than not much better, but slightly better than neural network. But the reason why I chose neural network, not random forest, was to see how would neural network react to learn non-linear relationships between data. But random forest was a good method for small data sets, because when they want to create many decision trees, we have more features, so more decision tree, and it would take time. It would be a time-consuming process. For k-mean clustering, I implemented it because I wanted to see how an unsupervised version of model would work on our problem, and if we don't have labeled data, how would we cope with the situation, and how would it react. And it didn't turn out very good. As we can see, the accuracy was really low. It was about 68%. But what features matters the most? Here we got it from the random forest. As we can see, the spam keyword count. So the spam keywords that I chose, it checked the email to see if we have them. That's the most important feature. And for the last port, which was the port E, for port E, I analyzed the ethical and environmental impact of my implementation. My spam keywords are English only, so this means they could only work on English language. They wouldn't be able to work on other languages. The other issue I had was my dataset. My dataset was really old dataset. It was for about 2002 to 2005. But there are accessibility concerns as well, because sometimes I run everything, and I get slightly different results in terms of accuracy, and for example in my confusion matrix. But regarding the environmental sustainability, I wanted to address my model is very lightweight compared to large language models. The training of it took about 30 seconds versus it takes days for large models. My model size was about a half a megabyte, and we don't need any GPU work for computing the results of these models, so it's very energy efficient. For production deployment, I could further reduce the environment impact by changing the model. But in conclusion, I successfully built a neural net for spam detection and I achieved about 96% accuracy. I exceeded my goal. So I checked supervised learning, which was neural network and random forest for this problem. I also check unsupervised learning and learn about it. On the other hand, I learned about feature engineering and how extract the features, how to see which feature is more important and use that feature, scale it using a standardization to calm down the effect. And the model has practical limitation, including the language bias, which needs update in future. But overall, the challenges were seen and faced.